Hello my lovelies, it's Susanna, and today I want to show you how to work with a logarithm. We're going to take a look at many examples how to use these three basic logarithm rules, and at the end we're going to take a look at this big example where we have to apply all the rules in one example. But let's start with the first rule here with our first example. The first logarithm rule tells us what we are allowed to do if we have a product in our logarithm. This rule tells us that as soon as you have a product in your logarithm, you are allowed to write this as two separate logarithms that are connected by a plus. So let's apply this rule here to our log expression. We have 3 times a in our logarithm, so we have a product in here. We are allowed to apply this rule. So we are allowed to write this one logarithm as 2 logarithms that are connected by a plus. What is in my logarithms? Well, in the first one, I write everything that is in front of my multiplication symbol. So I only have the 3 here in front of my multiplication symbol. So I take the 3 and write it in my first logarithm. And in the second logarithm, I have everything that comes after my multiplication symbol. So after my green multiplication symbol here, I only have the a, so the a goes into my second logarithm, and this is the first rule applied to this expression here. So we use the rule from the left side to the right side, but in our second example, that is here, we're still going to apply the first rule, but this time from the right side to the left side, because it also helps us if we have 2 separate logarithms that are connected by a plus. What do we have here? 2 separate logarithms connected by a plus, and this rule also tells us now that we can connect these 2 logarithms and write it as just one big logarithm. So we have log base 4 here, and here also log base 4. That is super important that you take a look at your bases as well. I mean, in the rule here, there is no base at all, but that just means that you can apply these logarithm rules to any base, so the base doesn't matter, but the bases have to be identical. Otherwise, you're not allowed to use the rule. So take care of your bases. They are identical, so we are allowed to apply the rule. What does the rule tell us now? Well, we are allowed to write this as one big logarithm. We have to keep the base, so we keep base 4. And what is in our log now? We're going to have a product. Okay, a product of what? Of the thing that was in my first logarithm, that is my b in this case, and the thing of my second logarithm. So in our case, it is a 1 over a. So just multiply the things that were in our logarithms and write it in here. You can leave it like this or write it as one fraction if you want to. So b times 1 just equals b. So if you want to write it like this is also a possibility. But in general, this was the first rule applied from the right side to the left. So every time you have a sum of 2 logarithms, you are allowed to write this as one big logarithm. Okay, second rule. The second rule tells us what we are allowed to do if we have a fraction in our logarithm. So not a product anymore, so not x times y, but the second rule takes a look at x over y. And it tells us that we are allowed to write this as 2 separate logarithms again, but this time connected by a minus. So let's apply this rule to our example here where we have a fraction in our logarithm. So we are allowed to apply the second rule and write this one big logarithm as 2 separate logarithms. So we have log base 2. So don't change the base, just write it down. And then we write a minus and write down the second log with the same base. We don't change the base. But what do we have in our logarithms now? In the first, we're going to have the numerator of our fraction. So everything that was on top of this fraction here, the 5x, go into the first logarithm. And in the second logarithm, we're going to have everything that was in the denominator. So we take the 3y and write them in our second logarithm. And this was the second rule applied from the left to the right side. But of course, we can take a look at the other way around as well. If we have two logarithms that are connected by a minus, what we have in this example here, we are allowed to write this as one big logarithm. So what do we get here? We check first that our bases are the same. We don't see any base here. We don't see any base here. So these are the same bases. We have a minus between these two logs. So we are allowed to apply the second rule and write this as one big log. And we're going to have a fraction in here that consists of my x, so everything that was in my first log, the 7ab, I'm going to write this on top, and the denominator is everything that was in my second log, so the 8x is going to be my denominator. And this was the second rule applied in this direction, and we're going to take a look at the third rule. This rule is one I use really often. It allows us, if we have a power in our logarithm, so x to the power of a, this rule tells us that we can take this exponent, the a, and write it in front of the logarithm. So we take the a and write it in front of our logarithm. So this a from inside the logarithm jumps outside of the logarithm, and only the base, so only the x, is going to be left in here, and these two are connected by a multiplication symbol. Let's apply the rule to this example here. We have a power in our logarithm. This is our exponent, and according to the rule, we are allowed to take this exponent and write it in front of our logarithm. So we take the 3, multiply it by our log, and then only the base is left in here. So not the 3 anymore. We already took the 3 in front of the logarithm, but this is everything we needed to do. And it also doesn't matter how complicated your exponent looks like. So even if we take a look at this example here, where our exponent looks a little bit more complicated, we are allowed to apply the same rule that we can take this exponent and write it in front of our logarithm. So we take this exponent, 2x plus y, write it in parentheses because all of that needs to be multiplied now by the rest. So by log, and then only the base is left in here because we took the green part out in front of the log, and only the a is left in our logarithm. This was this way around. Now we're going to apply it the other way around, where we have a factor in front of our logarithm, and we want to drag it in our logarithm. So something like this. We have a factor, so 7 times our log, and we want to take this factor and write it in our logarithm as an exponent. So we are allowed to just write down the log of our base, of our y, and now we take the factor that was in front of my log, and this 7 is going to be my new exponent in my logarithm then. And this rule can be applied no matter how complicated this factor here looks. So let's take a look at a second example where we have this factor here in front of our logarithm. The only thing that is important is that it is connected by a multiplication symbol. So we have a factor that is connected by a multiplication symbol, and then the rule tells us that we are allowed to write this as one big logarithm. And what is inside now? Everything that was inside before, so everything that was here was the 2a, but now we're taking the factor that was in front of my log and write it as an exponent in here. So we take the 3b and write it as an exponent inside of our logarithm, but we have to be careful. If I just take the 3b and write them like this now, this is just an exponent for the a, but we want this to be an exponent for everything that was inside here, so we have to write all of this in parentheses, and then all of this is an exponent for everything that was in here. So write everything into parentheses and then write down your exponent. Okay, as promised, we're going to take a look at our big example where we try to apply all of these rules in this one example. And there is not one way how to do it. You can combine these rules however you like. If you don't make any mistakes, it should result in the same result in the end. So let's see what we can do here. First of all, if we take a look at the bases, they are all the same, which is great. So we are allowed to apply the rules. Maybe we start here where we have a factor in front of our logarithm. So what we are allowed to do is take this factor and write it as an exponent in our logarithm. Let's start here. So we have log of x, so everything that was in here, and this green factor is going to be my new exponent inside here. Everything else, I write down how it is right now. We get used to what we have here. We have a minus log, a plus log. We have a fraction in a log. Okay, we know that there are rules to change this, but I don't want to touch it right now. Maybe now we see that we have a minus between two logarithms here. So let's connect these two, let's combine these two. We've seen a rule how to do it, the second rule, that we are allowed to write this as one big logarithm. If we have a minus between two logs, this is going to be a fraction in a log. The first thing that was in my log is going to be my numerator. The second thing that was in my second log is going to be my denominator. And then I still have plus log of the rest, but this looks good so far. So this is what we have now. What else can we do? Well, this time we have a plus between two logarithms, so the first rule tells us that we are allowed to combine this and write it as one big log. If we have a plus between them, it's going to be a product then in the logarithm. We take the first thing from our first logarithm, so x squared over 4. This is going to be the first part. And the second part is going to be what was in the second logarithm, so 4y over x. And now we only have one big logarithm, so we don't do anything anymore, but simplify what is in here. We have a product, and we can cancel things out if it's possible. So the 4, for example, cancels out, and we have x squared here and an x here, so one of these x's can be canceled out as well, so that in total we only have x times y, and in the denominator there is nothing in here anymore, so there are only ones, so 1 times 1 equals 1, and we don't have to write it down at all. So this is our simplified version of this big expression. I hope it helped you. If you have any questions, please let me know in the comments. I wish you a wonderful day, and I hope to see you in one of my next videos. Take care!